So natural deduction is a proof procedure by which the conclusion of an argument is validly derived from the premises through the use of rules of inference. A proof is a sequence of steps in which each step is either a premise or follows from earlier steps in the sequence according to the rules of inference. Rules of inference justify the steps of a proof. There are two different kinds of rules of inferences. There are rules of implication and rules of replacement. So we're going to talk about these a little bit more, and I'll actually illustrate what we mean here as we continue on. Let me start with rules of inference, okay? Now, there are two types of rules of inference. Those are rules of implication as well as rules of replacement, otherwise referred to as replacement rules and implication rules, okay? Now, here we have 4 rules of inference, which are implication rules, okay? And if you look at them, notice that they are actually valid argument forms, okay? Here we have the modus ponens, the modus tollens, pure hypothetical syllogism, and disjunctive syllogism, okay? So these are all valid argument forms. Now, although they are valid argument forms, they are also rules of inference, okay? So you can use them in order to validly derive a conclusion from given premises. Why is this the case? Well, consider this, okay? If it's the case that we have, let's say, the modus ponens, P then Q, okay? P so Q. Let's say you have this argument. And you can ask yourself, okay, according to this argument, okay, given these premises, P, then Q, and P, we can conclude Q, okay? But what is it that makes it possible for us to conclude Q based on these two premises? What makes it possible is a rule of inference. And that rule of inference is basically the form P, then Q, P, so Q, okay? As an inference rule, okay? As an inference rule, okay? What this form is telling you is that anytime you have a premise P, then Q, and you have a premise P, you are allowed to conclude Q, okay? So, given this as an inference rule, if we have premise P, then Q, and premise P, then this rule allows us to conclude Q. So notice how this inference rule is not only an inference rule, but it is also an argument form, and vice versa, okay? So we can use these forms as argument forms to construct deductively valid arguments, as well as inference rules, okay, in order to justify the conclusion of a valid argument, okay? Okay, so you're going to have to, as we continue on with doing natural deductive proofs, memorize these argument forms as rules of inference, okay? I will tell you this right now. If you do not have these argument forms memorized as rules of inference, you will have a lot of difficulty with doing natural deductive proofs, okay? And it is very, very important that you practice doing natural deductive proofs, employing these inference rules, okay, in order for you to be good at it, okay? Okay, so let's move on. The fallacy of affirming the consequence, as well as the fallacy of denying the antecedent, as we've discussed, are not valid forms of argument, okay? So these are valid, however, these are invalid, okay? So because these two are invalid forms of argument, they cannot justify the conclusion of an argument, okay? So in this case, these are not to be used as inference rules, okay? So no invalid form is used as an inference rule. Only valid forms of arguments are used as inference rules, okay? Now, notice how these, as inference rules, what they do is tell you that given two premises of a certain kind, okay, you can conclude these conclusions, okay? Which means that these are rules of implication, okay? They tell you that these two premises imply the conclusion, okay? And these two premises imply this conclusion, and these two premises imply this conclusion, and these two premises imply this conclusion, okay? So these are rules of implication. When you're memorizing these as inference rules, one thing that will be really, really helpful for you to do is actually not just memorize the form itself, but think of the rules in terms of what the rules will allow you to do, okay? So for example, let's say you're memorizing the modus ponens, okay? What you should do is think of the modus ponens form in this way as an inference rule. If you have a conditional statement, okay, as well as a statement that is the antecedent of the conditional statement, okay, then modus ponens allows you to conclude the consequent, okay? And then here for the modus tollens, if you have a conditional statement as a premise, and then you have the negation of the consequent of that conditional statement, okay, then modus tollens allows you to conclude the negation of the antecedent, okay? And then here the pure hypothetical syllogism. If you have two conditional statements as premises, where the consequent of one is the antecedent of the other, okay, then pure hypothetical syllogism allows you to conclude a conditional statement made up of the antecedent of one of the conditional statements, specifically the one that has the similar statement as the consequent, and the consequent of the other conditional statement, okay? Specifically the one that has the similar statement as the antecedent, okay? And then finally, for the disjunctive syllogism, if you have a disjunction as a premise, okay, and then you have the negation of the first disjunct, okay, then disjunctive syllogism allows you to conclude the second disjunct, okay, the one that's not being negated, okay. So one thing that you can do is memorize these argument forms in terms of inference rules, okay, as rules that allow you to do things, allow you to draw certain conclusions based on certain given premises, okay? Okay, so let's move on to how to do natural deductive proofs, okay? However, before we do so, a warning, okay? Before we continue, please make sure you are very familiar with the first 4 implication rules. You might have a real difficult time understanding what follows if you don't. If you need to pause the video and familiarize yourself with the first 4 implication rules, modus ponens, modus tollens, pure hypothetical syllogism, and disjunctive syllogism, please do so, okay? Okay, so the general method of natural deduction. I'm going to go through the general idea of how natural deductive proofs work, and then we're going to do a bunch of examples, okay? So first of all, the purpose of a natural deductive proof is to prove that the given argument is valid by deriving the conclusion using only the given premises, inference rules, and any conclusion validly derived from the given premises and an inference rule. Here's the setup of a natural deductive proof. Notice here we have all the premises, okay, of an argument, and along here with the slash on the other side we have the conclusion, okay? So this is an argument, okay? Not only is it an argument, it's a valid argument, okay? What we want to do in doing a natural deductive proof is to prove that it is valid, okay? You cannot use natural deductive proof in order to determine whether or not an argument is valid. You can only use it in order to prove that what you already know is a valid argument is valid. Why is that? Well, here's the thing. If it's the case that this is actually not a valid deductive argument, you'll never be able to prove it, okay? However, the fact that you won't be able to prove an argument, okay, using natural deductive proof, doesn't necessarily determine that it's invalid. Why is that? Because you might be doing something wrong, okay? It might be that it is a valid argument, but you just don't know how to prove it. okay? So you can't use the idea that not being able to prove it means that it's invalid, okay? Because it might be an issue lying with you rather than with an argument. So you can only use natural deductive proof to prove that what you already know is a valid argument to be valid, okay? Okay, so these are the premises that we're going to work with, and for the natural deductive proof, you can think of it kind of as a game. So we have here, these are the premises, okay, and this is the conclusion, okay? So here's the conclusion, and these are the premises of our argument, okay? So we have 1 through 4 being the premises and our conclusion here. And what we want to show in our proof, okay, in our game, that we can get this conclusion here, okay, as the last line of our proof. So down here at the bottom, okay, using only these premises that have already been given to us, as well as the inference rules that we have been given, the 4, modus ponens, modus tollens, pure hypothetical syllogism, and disjunctive syllogism, okay, and any conclusion that we can derive from these premises as well as the inference rules, okay? So let me show you a little bit more in detail. So the first step that we want to do when we have a natural deductive proof, okay, is understand that these are the premises and this is the conclusion that we want to derive. And we want to look at the premises and see if we can find the conclusion as it is given or the parts of the conclusion in the premises, okay? Notice that in these premises, okay, we find the conclusion here, right here, okay, as it is given, okay? So what we want to do is be able to use eventually this premise here, okay, because it's the only premise that has the conclusion, okay, in order to get to this conclusion as the last line, okay? So there's a top-down and a bottom-up method, okay? So these are 2 different strategies of how to do natural deductive proof. I'm going to show you how bottom-up works, and then we can also work on how top-down works, okay? So that you can kind of be familiar with both these methods. Sometimes you might have to work from both bottom-up and top-down at the same time, okay? Especially if you have really long proofs, okay? So I'll show you this as we continue on. Okay, so working from bottom-up. Now, we have this premise here, tilde P then Q, okay? So it's premise number 4, and premise number 4 is tilde P then Q, okay? And we're going to make some hypotheses now, okay? We're going to say, look, we need to get Q eventually as the conclusion, as the last line of our proof, okay? So in order to get Q then, is it possible for us to use this here, this premise, okay, along with some inference rule and some other premise in order to get Q, okay? Well, if you think about it, there's only one rule that will allow us to conclude the consequent of a conditional statement, okay, which this Q is. And that rule is modus ponens, right? So modus ponens is if P then Q, and you have P, then you can derive Q, okay? So if we use modus ponens here as an inference rule, okay, then we can use this premise along with another premise to get Q, okay? However, we're going to need that second premise. And if we look at what the inference rule is, it'll tell us what that second premise will be that we need. Here, the inference rule tells us that we need the antecedent of the conditional statement, which in this case is not P, okay? So, we're hypothesizing that if we have these 2 premises, okay, then we can use the inference rule of modus ponens to get Q, okay? However, notice that although we have this premise here, the first premise, okay, we don't have this second one, okay? So we're moving bottom up. We're moving from the conclusion up towards the given premises, okay? So here we have one premise, but now we need to get this as a conclusion, okay? This not P, okay? So next step, going this way, okay? And this is working bottom up. We're gonna want to look for tilde p, okay? So now this is our new conclusion that we want to derive, okay, using these premises here and the inference rules given to us, okay? Because once we get this, we can actually use it here in order to get the Q as the conclusion, okay? So now we start kind of like the same strategy over again, so as this being the new conclusion, okay? So we look at not P as the new conclusion, and we see if we can find it somewhere here in the premises or parts of it in the premises, okay? Now, notice how here we have the not P here in the antecedent of 4, okay? However, there is no inference rule that will allow you to conclude the antecedent of a conditional, okay? So given that, we know that we are not going to use this statement 4 here in order to get not P, okay? However, notice that we have P here, and that makes up part of this conclusion, not P, okay? So P here is the antecedent of a conditional statement, okay? And if you think about it, you can actually use an inference rule to conclude the negation of an antecedent of a conditional statement. So if P is the antecedent here, the negation of P will be not P, okay? So we can actually use 2 here as a premise, P then S, okay? And a inference rule, okay, along with another premise that will allow us to conclude not P, okay? What is that inference rule? That inference rule is modus tollens, okay? So modus tollens is P then Q, okay? Not Q, so not P, okay? So this inference rule allows us to conclude the negation of the antecedent of that conditional, okay, given this other premise, okay? So if we have this statement here as a premise, what will we need according to this inference rule, which is the modus tollens, in order to conclude the not P? What we will need is the negation of the consequent, which in this case is not S. Okay, so the negation of the consequent, okay? So if we had these 2 premises, then using this inference rule, we can conclude this as a conclusion, tilde P. And if we had tilde P as a conclusion, then we can use it along with this premise and the inference rule modus ponens to conclude the conclusion Q, which is ultimately what we want, okay? Are we done yet? No, okay? Why? Well, do we have not S as a premise, okay? Well, do we have it here given to us, okay? If we look here, we don't have not S given to us as a premise. So we're going to have to derive S now. So our next step, okay, so we're moving this way, which is actually bottom up, okay, is to get not S as a conclusion. Because if we can get not S as a conclusion, we can use that here along with this premise and modus tollens to get not P. And once we can get not P as a conclusion, we can use that premise here in order to get Q, okay, by using this premise and modus ponens, okay? So next we have to look for not S. How do we look for not S? Well, we see if we can find it in our given premises, okay, as it is given or parts of it, okay? Notice how we have a not S right here, okay? So we have a not S here, and it's part of a disjunction, and if you think about it, there is one inference rule that will allow you to conclude the second disjunct of a disjunction, okay? And that is the disjunctive syllogism, okay? So if we had this statement here, which we do, okay, statement 3, which is R wedge not S, we can actually conclude not S, okay, using disjunctive syllogism, DS, okay, along with another premise. And disjunctive syllogism, the form of that is if we have P or Q, okay, and we have not P, okay, then we can have Q, okay. So here, Q is the second disjunct. So here we have not S as the second disjunct, okay? But in order to conclude this Q, okay, the second disjunct, here, the not S, okay, which is the second disjunct, we need not P, okay, which is the negation of the first disjunct. In this case, the negation of the first disjunct will be not R, okay? So now we have to ask ourselves, well, do we have not R, okay? Can we get not R? Because once we can get not R, we can then, by use of these two premises and this inference rule, disjunctive syllogism, conclude not S, which will then allow us to conclude not P by using this premise as well and modus tollens, which will then allow us to conclude Q by using that premise and this premise as well as modus ponens, okay? So, now what we want to know is if we can get not R. Do we have not R as one of the given premises? Yes, we do, okay? And notice how we have not R here, okay? So, we have not R here, which means I'm going to go ahead and give that number here. So now here, notice that both the premises that I needed in order to get a conclusion that I needed are rooted in the given premises, okay? Because this is the case, I can stop with working out my proof, okay? I haven't actually written my proof out yet. This is all work that you're going to be doing on scratch paper, okay? This is to work out your proof before you write your proof down, okay? So here, notice both the premises that I need will allow me to get the conclusion that I need, okay? And once I have these two premises, I can conclude this one. And once I have this one, I can use it in order to conclude this one. And once I have this one, I can use it in order to conclude this one. Now, we've worked from bottom up, okay? So what you want to do when you write out your proof is write it out top down, okay? When you write out your proof, you want to start from the premises given to you, okay? And then work towards the conclusion that you ultimately want to get. Each line of proof will be a conclusion drawn from premises and an inference rule, okay? So you will have a conclusion on one line of proof, and next to that you will have the premises that you use in terms of their identifying number, okay? And then the inference rule, okay? This is necessary, okay? The conclusion will be the conclusion that you've derived, and the premises will be the numbers that correspond to the premises, and the inference rule will be the inference rule you use, okay? And the premises and the inference rule together will be called the justification for the conclusion you've derived, okay? Furthermore, each time you've derived a conclusion, you are allowed to use that conclusion in any subsequent proofs, okay? So, when I write out my proof for what I've worked out here, okay, what I'm going to do is first write out the conclusion, okay, not the premises, the conclusion that I've derived from the two premises that are rooted immediately in the given premises, okay, which is this here. So here we've used premise 3, okay, premise 3, so I'm going to erase this so you can see it, okay. So here we've used premise 3, okay, along with premise 1, okay, premise 1, in order to conclude not S. So I'm going to put not S as my conclusion for line number 5, okay, so 1, 2, 3, 4, my next line is 5, okay. My conclusion is not S, and I've concluded this using premise 3 and premise 1 as well as disjunctive syllogism, okay. So you have here premise 1, premise 3, disjunctive syllogism. It's okay whatever order you put premise 1 and premise 3. Like you can switch these as well, that's fine. Okay? Now, the next conclusion that I've drawn, okay, now I'm working backwards, okay? So in order to figure out my proof, I worked bottom up, but in order to write it down, I need to write it down top down, okay? So my next conclusion that I can draw after I've concluded the not S, okay, is this conclusion here. Because remember, we hypothesized. Once we could get this conclusion here, the not S, we can use this conclusion with the premise number 2, okay, as a premise, okay, in order to conclude not P. So our next conclusion, conclusion number 6, will be not P, okay? And the justification of this will be the 2 premises that we've used, which is premise number 2, okay, P then S, as well as premise number 5, okay, because this is something we've concluded before we conclude this, so I can use this conclusion now as a premise, okay? So we can use this as another premise, and that's here, premise 5, okay, along with the inference rule modus tollens, okay? So that will be our justification, premise 2, premise 5, and modus tollens, okay? And then finally, we can conclude, after we conclude not P, okay, we can use that as a premise. We can use not P as a premise, okay, along with this premise here, premise 4, okay, in order to conclude Q, okay? So Q is our final conclusion, okay, line 7, and the justification for this will be this premise here, along with this premise here, which is premise 6, and the inference rule MP. So here will be the justification, okay? So now that we've shown that we can derive our conclusion that we're looking for, okay, using these premises that were given to us, as well as the inference rules that were given to us, and any subsequent conclusions we've derived from these premises and these inference rules, we have completed our proof, okay? So now we are done. The proof is this here, okay? The conclusions along with the justification, okay? However, all this stuff is scratch work that you will do in order to work out your proof, okay? And the way we worked out our proof in this case was to go from bottom up, okay? We looked at what we needed for our conclusion and hypothesized, well, if we had this, then we can get this. And if we had this, then we can get this. And if we had this, then we can get this, so on and so forth. Until, at the last end, we were able to root our conclusion into the premises that were already given to us. Notice how both of these premises were premises that were given, okay? So then when we write out our proof, because we worked bottom up, we're going to write out our proof always top down, okay? So there is how you do a natural deductive proof for a deductive argument that is already valid. Okay, so I'm going to step back here so you can kind of take it all in.